All right, so I forgot that I was supposed to record this, so I'm going to kind of just go over the things that I've said already. This is from section 4, topic 2, and we are solving quadratic equations by factoring. I will post another video on Edmodo that I got from Khan Academy that's about factoring, solving quadratic equations by factoring. They use a different method, so when you watch that, it's a different way to do it. They're not doing it the way that I do it, okay? So if you're confused by my method, go watch theirs, but it's going to be different. There's like 6 different ways to do it that I know of, okay? Bless you. So what I've said so far is you want to make sure that your equation is set equal to 0 and in standard form if it's not already, which this one was. If it's not, you need to get it that way before you start doing anything else, okay? The next thing you want to do is you want to look for a greatest common factor. If there is one, you've got to factor it out. So this equation had a greatest common factor of 3, so that's where we are right now. So I write my 3 outside parentheses, and then to figure out what is left after I factor it out, I divide each term by 3. Whatever's left goes inside parentheses. So what's 36x squared divided by 3? 12x squared. What's positive 60x divided by 3? Positive 20x. And positive 21 divided by 3? Positive 7. And if you're not sure, you could check yourself. You could distribute in your head. 3 times 12x squared is 36x squared. 3 times positive 20x is 60x. 3 times positive 7 is positive 21. Okay? So we did not do anything incorrectly. So the next thing you want to do is define A, B, and C. So since we have changed the original equation, we're not factoring that anymore because we took out a greatest common factor. Okay? So when we define A, B, and C in this case, A, B, and C come from what's inside the parentheses. So A is 12, because A is the coefficient of your quadratic term. B is 20. B is the coefficient of your linear term. And C is 7. That's your constant. Make your little T-chart. And on the left, you want 2 numbers that multiply together to give you A times C. And on the right, you want 2 numbers that add together to give you B. Okay, so let's see what A times C is. So A is 12, C is 7. So 12 times 7 is 84, and that's a positive 84. And B is positive 20. So let's just think of 2 numbers you could multiply together to get 84. Any ideas? 6 and 14? Let's see. 6 times 14 is 84. And 6 plus 14 is 20. So that works. What if I didn't pick that first and I said, well, I know 12 times 7 gives me 84 because that's how I got 84 to begin with, right? 12 times 7. But 12 plus 7 is 19. Could I use 12 and 7 if I wanted to? No. I can only pick the 2 numbers that make both sides true. The 2 numbers that multiplied together to give me 84, and the 2, multiplied together to give me 84, and the 2 numbers that added together to get 20. Okay? Has to make both sides true. So the 12 and 7 made the left side true, But 12 plus 7 did not make 19 true. Okay? So if you go back to your notes, it said, now make your parentheses. That GCF is still going to go outside the parentheses. You make 2 sets. And whatever variable that's used in the problem, that's going to be the first term in each set. So they used x's, so we'll put an x as the first term in each set of parentheses. Sometimes they'll use k's or m's or n's or whatever. So whatever variable they're using, that's going to be the variable you put as the first term, okay? Then the second term in each set of parentheses comes from the T-chart. It's the 2 numbers that worked on the left and the right. And the signs are important, okay? These were both positive. So put a positive 6 in one set of parentheses, a positive 14 in the other. Now this is where a lot of kids forget about it and they think this is the answer, okay? It's not yet. This is where the old divide and slide comes in. So whatever A is, now A is different than the original A, okay? Go to the A in the T-chart, because if we took out a GCF, your A may have changed. So look at the A in the T-chart. We are going to try to divide both of the numbers that we took out of the T-chart by whatever A is. This is where we get the name divide and slide. Really, it should be called divide or slide. Now, if it's a slide, you must reduce before you slide. You just make a little note of that. If it's a slide, you must reduce before you slide. The GCF, you still keep the GCF on the outside of the parentheses, okay? It does not go away. It's a factor. So let's look at 6/12. Can I, the 6 divide by 12 evenly? The 6 divide by 12 evenly? No. So then we would call it a slide. So if it's a slide, we must reduce before we slide if you can. Can you reduce 6/12? Yes, to what? 1/2. 1/2. So I'll rewrite that as x plus 1/2. I reduced. And how about 14/12? Can you reduce that? Does not, the 14 and 12, do they not divide by 2 evenly? Yes, so I'll reduce 14/12. So 2 goes into 14 7 times, 2 goes into 12 6 times. So these are both going to be a slide, okay? If they do not divide evenly, they're a slide. You divide or you slide. Since they don't divide evenly, they're a slide. So what you do is take that denominator, move it up, and make it the coefficient of the variable on both of these, okay? So you still have the GCF of 3, and then I'll slide the 2 in front of the x, so that'll be 2x, and then bring down your plus 1. In the other parenthesis, I'll slide the 6 in front of the x, so that will be 6x, and then just bring down plus 7. Once you do the divide and slide part, then you're completely factored, okay? You're in what's called factored form. We started in standard form, ax squared plus bx equals c. Now we're in factored form. A lot of times in the directions, that's all they want you to do is factor. So if you just had to factor, these are my factors. I've got 3 of them. 3 is a factor, 2x plus 1 is a factor, and 6x plus 7 is a factor. However, what we're doing is using factoring to solve equations, okay? So we're factored, but we're not solved yet. So to solve, set each factor equal to 0 and solve for x. So set each factor equal to 0 and solve for x. It's a pencil sharpener up here that works better than that. It's the electric one up here. Alright, so I'll set 3 equal to 0. I'll set 2x plus 1 equal to 0. And I'll set 6x plus 7 equal to 0. Now the GCF, there was no variable in that. Does 3 equal 0? No. So 3 was a factor, but when it comes to finding the solutions, it doesn't give me a solution. Okay? Your solutions are going to come from only the factors that had a variable in them. So over here, I'll subtract 1 from both sides. So if 2x equals negative 1, divide by 2, and x equals negative 1/2. So there's one of my solutions. And the other one, I'll subtract 7. So if 6x equals negative 7, divide each term by 6, and x equals negative 7/6. So these two solutions, when we get to graphing quadratics, you know that's going to make a parabola, right? Those two solutions tell us where the graph will cross the x-axis. That's what it's telling us. Which in the next example, we'll sketch a little graph. Okay, I'm just out of room here. But that's what we're finding. When we solve a quadratic, the solutions tell us where the graph will cross the x-axis. Those are two really important parts to a graph of a quadratic. And those solutions are also called roots or zeros. So sometimes on a test it may say find the roots. That means find the solution. It may say find the zeros. It means find the solution. It may say find the solution. Okay? But roots and zeros are the same thing as what we just found. All right, let's look at the next example. And if you were in my first period, these example numbers do not match up with your notes. They're a little bit off. This next example would be the first one that we did today. But it's our third one. So we have b squared equals negative 6b plus 16. And make sure that looks like a b and not a 6. So b squared equals negative 6b plus 16. So if you go back and look at your notes, the first thing you do is get it set equal to 0 and in standard form if it's not already. So is this set equal to 0 and in standard form? No. Now it would be easiest just to move the b squared over to the right, but b squared is going to be our leading term because it has the highest exponent. So we want it to stay positive. Okay, you don't want it to turn negative. So I'm going to take both of these terms and bring them over to the left side. And I'm just going to do that in one step. So I will add 6b to both sides. And I will subtract 16 from both sides. So on the right side, everything cancels and just leaves me with 0. On the left side, in standard form, remember you put your term with the highest degree first. So you have b squared plus 6b minus 16. b squared plus 6b minus 16. Next thing you do is you look for a greatest common factor. Do we have one? No. So you just move on. Define A, B, and C. What is A? 1. What is B? 6. And what is C? Negative 16. A is the coefficient of your quadratic term, B is the coefficient of your linear term, and C is the constant. Okay? Sometimes you'll be missing the linear term or the constant. If you're missing one of those, you just put 0 in the spot of whichever one you're missing. But you can't be missing an A. If you're missing an A, it's not a quadratic. Okay? So make your little T-chart. And on the left, you're looking for two numbers that multiply together to give you AC. And A times C is negative 16. And on the right, you want two numbers that add together to give you B, which B is a positive 6. Just give me two numbers you can multiply together to get negative 16. It does not matter if it makes both sides work. I actually prefer that it didn't, just so we could see what happens when they don't. Okay, let's see. 4 times negative 4 is negative 16. But do not stop there. It's got to make the right side work as well. What's 4 plus negative 4? 0. So can I use 4 and negative 4? No. All right, let's try that. Negative 8 and positive 2 equals negative 16. Negative 8 plus 2 equals negative 6. Is that going to work? So close. How could we change it? All right, let's make positive 8 and negative 2 because we still get negative 16. But 8 plus a negative 2 gives me a positive 6. So now that we've made both sides true, now we know what to use. So make two sets of parentheses. We don't have a greatest common factor, so there's nothing to put on the outside. The variable is B, so B will be the first term in each set of parentheses. And the numbers, positive 8 and negative 2, I got that from the T-chart. It made both sides of the T-chart true. Now what do we have to do? Before that, got to do the old divide and slide, right? Whatever A is, we divide or we slide both of those numbers from the T-chart. Now what happens when we divide by 1? Nothing changes, right? So is it really necessary if A is a 1? No, but I'm going to do it every time because I don't want us to forget that step, because when A is any number other than 1, it will change. So that gives me B plus 8 and B minus 2. So if I were just factoring, these would be my factors. If I distributed everything out, B times B is B squared. B times negative 2 is negative 2B. 8 times B is positive 8B. Combined like terms, that gives me 6B. 8 times negative 2 is negative 16. I factored correctly. But I am using factoring to solve. So to solve, set each factor equal to 0. And solve for the variable. So my answers are negative 8 and positive 2. And I'm also going to make a little note on the side that the solutions are also called roots and zeros. And I also said the solutions tell you where the graph will intersect the x-axis. Okay, y'all good with that? Let me just do a little quick sketch here. I want to look on my calculator. I'm going to teach y'all how to graph these by hand. But for now, I put in x squared plus 6x plus 16. I use x instead of b because y'all know with a calculator you just use x, right? And so my graph looks like that. Let me zoom in a little bit. Whoa, not that far in, but you can see up at the top. And let me change my window. Well, oh, you can see it on my TV screen. It's just the glare. Hold on. Why? Okay, so can you see it crosses the x-axis right here at positive 2? And then negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, negative 8, and at negative 8, right? So it just tells you where the graph crosses the x-axis. So when we have to graph these by hand, those are two really important points on your graph. And when you find them, you'll be able to plot those 2 points. Now this vertex, y'all remember if I want to find this, is this a maximum or a minimum? A minimum. So if I wanted to graph this, which I am going to put a quick sketch on my paper, remember I do second calc, minimum's option 3, left bound, I just move the cursor just a little left of that minimum point, enter, right bound, move it just a little to the right, enter, and you always enter through guess. It's at negative 3, comma, negative 25. So I'm just going to throw a quick sketch on my paper. And I'm not going to graph all of them. I just want us to have and it's not perfect because, well, it's hand drawn. So you're finding the x value of the solution. The y value is obviously 0. Any point on the x-axis has a y value of 0, right? So that's how I knew what the ordered pair was. And my vertex is supposed to be at negative 3, comma 25. So what would be the equation for my axis of symmetry? What would be my equation for the axis of symmetry?
It'd be x equals negative 3.
X equals negative 3. Has the same x value as my vertex. Coolio? Coolio. Okay. Moving right along. Like I said, we're not going to do that for all of them. I just want to have that in your notes. Anybody have questions so far? After I do my notes, you all are going to have a classwork assignment that's due today on your own. So those of you who are sleeping, don't even ask me to come help you. It's not going to happen. You'll have to ask the people who don't mind helping sleepers. Okay? Okay? And then you also have a homework assignment. Okay? So the quicker you get the classwork assignment finished, the quicker you can turn that in, which I'm grading, and then I will give you your homework assignment. All right, example 4. We have 2m squared equals negative 10 plus 12m. 2m squared equals negative 10 plus 12m. Is this set equal to 0 and in standard form? No. My highest degree is 2, and that term's positive. We want to keep it positive. Even though it's easier to move it to the other side, we don't want to do that because we don't want our leading term to be negative, okay? So I'm going to add 10 to both sides, and I'm going to subtract 12m from both sides, so that I wind up with 0 on the right side. And on the left side, I have 3 terms. I've got to put them in standard form. So my highest degree comes first. That's 2m squared. My next highest degree is 1, so that's minus 12m. And then 10's my constant. It has 0 degrees. It always comes last. Right on? Crouton. Next thing I do is I look for a greatest common factor. Do I have one? Yes. What is it? 2. So I have to factor it out. So put the GCF outside the parentheses. Make a big parenthesis. And to figure out what's left, you divide every term by the GCF. So what's 2m squared divided by 2? Negative 12m divided by 2. Positive 10 divided by 2. Okay? Now I still have a quadratic, so if we got to try to factor it. Now not everything's factorable. Every once in a while you're going to find a problem that's not factorable, but all the ones that I'm going to give you today are all factorable. So if you write non-factorable, it's not correct because I'm giving you all factorable problems today. Okay, so what is A? 1. What is B? And what is C? So make your little T chart. Remember last year? Short and stout. Yeah. I'm a little T chart, short and stout. All right, we need 2 numbers that multiply together to give us AC, which A times C is positive 5, and then add to give us B, which is negative 6. What you think? Negative 5 times negative 1 is positive 5. And negative 5 plus negative 1 is negative 6. So winner, chicken dinner. So make your parentheses. Don't forget your GCF on the outside. This time the variable they used is m, so that will be my first term in each set. My numbers are negative 5 and negative 1. It does not matter which number you put in which parenthesis, okay? But you have to make sure that sign is correct. And don't forget to divide and slide. Now in this case, we're dividing and sliding by 1, not the original A of 2, okay? But look at your GCF. If I divide and slide by 1, is that going to change anything? No. So if you don't divide and slide when A is 1, again, it's okay. It's not going to change anything. So my factors are 2, m minus 5, and m minus 1. What are those, my solutions? No. How many factors do we have? 3. How many solutions are we going to have? 2. When you have 2 degrees is your highest, that means you can have a maximum of 2 solutions. You can't have more than that. So you know you're not going to have 3 solutions. And you know 2 does not equal 0. So 2 is a factor, not a solution. Your solutions will come from the variables or I'm sorry, from the factors that had variables in them. So your solutions are positive 5 and positive 1. That's where this graph would cross the x-axis if we were to graph it. So in the last example, I graphed that problem. We didn't check it. In this example, I'm going to check it and not graph it, just so you have examples of both in your work. So I'm going to check m equals 5, and I'm also going to check m equals 1. So when you have to do your classwork, you don't have to call me over and say, is this right? I'm going to say, I don't know, did you check it? Okay? You can answer your own question. Self-sufficient. You'll know yourself, right? So I'm going to take, you can either take the original problem, or you can write down from once you put it in standard form and set it equal to 0. It doesn't matter. One or the other. But when I check m equals 5, wherever I see an m, I'll substitute in a 5. And once I do that, there's no variables in the equation anymore. So don't move anything from one side to the other. Just simplify the left side, simplify the right side, and see if they equal to each other. Okay? Order of operations. Remember PEMDAS. What do I do first? 2 times 5 or 5 squared? 5 squared is what? 25. I'll come back to it. On the right side, do I do negative 10 plus 12 first, or 12 times 5? 12 times 5, which gives me 60. So on the left, I can multiply. 2 times 25 is 50. On the right, negative 10 plus 60 is 50. Is 5 actually a solution? Yes, because it made a true statement when I substituted it back into the problem. Now I'll check m equals 1. So 1 squared is 1. So 2 times 1. And on the right side, I have negative 10 plus 12. On the left side, 2 times 1 is 2. On the right side, negative 10 plus 12 is 2. 2 does equal 2. True statement. So I know m equals 1 is actually a solution. Right on? Roots on. I have 2 more to do. Just 2. Quick problems. I would just do 1, but I want you to see this special something that happens in one of them. Do y'all have questions? You feeling more comfortable with this than yesterday? Of course, yesterday we only did one example. It was C day, but. Okay, so this would be example 5. And my problem is b squared minus 49 equals 0. Is it set equal to 0 and in standard form? Yeah, yes. Are we missing a term? Which term? B, right? We're missing the B term. Because our constant is always the C. Yeah, yes. We don't have to add it in, but when we define A, B, and C, it'll be a 0. Okay, is there a greatest common factor? No. So what is A? 1. What is B? 0. What is C? Negative 49. So I need 2 numbers that multiply together to get A times C, which A times C is negative 49, and that add together to give me B, which is 0. Alright, negative 7 times positive 7 does equal negative 49, and negative 7 plus 7 does equal 0. We got it. So make your 2 sets of parentheses. B is the variable, so that's going to be the first term in each set. Look at your T-chart to figure out what numbers you use. So -7 and a +7. If we divide and slide by A, is that going to change anything? Not in this one. A is 1. So my factors are just B minus 7 and B plus 7. So 2 factors. How many solutions am I going to have? 2. We haven't found them yet though, right? So to solve, we set each factor equal to 0 and solve for the variable. Coolio. Alright, I know we did that one fast, but it was a pretty easy one. Alright, last example. Example 6. (6x² minus 9x minus 27 equals 0. 6x² minus 9x minus 27 equals 0. Is it set equal to 0 and in standard form? Yes. Is there a greatest common factor? What is it? 3. Sweet. We gotta factor it out. Put a 3 outside your parentheses. To see what's left, we divide each term by the GCF. So 6x² divided by 3 is 2x². Negative 9x divided by 3, negative 3x. Negative 27 divided by 3, negative 9. We're not finished though. We still have a quadratic inside the parentheses. So now we're going to make our T-chart. So we need to define A, B, and C. What is A? 2. What is B? Negative 3. What is C? Negative 9. I need 2 numbers that multiply together to give me A times C, which is negative 18, and that add together to give me B, which is negative 3. Okay, negative 6 times positive 3 is negative 18, and negative 6 plus 3 is negative 3. So I have 3, open parentheses, 2 times. The variable they use this time is x, so that's going to be the first term in each set. The numbers come from the T-chart. Put a negative 6 in one set of parentheses, a positive 3 in the other. How important is dividing and sliding on this one? It's important because A is some number other than 1, right? So don't forget, do not divide and slide the GCF. Only the numbers that you got from the T-chart. That's the only thing you divide and slide on. If you can divide evenly, divide. If you cannot divide evenly, if you're going to get a decimal, you slide, but reduce before you slide if you can. So don't forget your GCF of 3. X minus 6 halves, divide or slide? Divide, and I get x minus 3. X plus 3 halves, divide or slide? Slide. Can I reduce? No. If I can, I have to reduce first. So just slide that 2 up in front of the x, and what do I write? 2x plus 3. Am I finished factoring? Factoring. I'm finished factoring, but have I solved? No. How many factors do I have? 3. How many solutions am I going to have? 2, because 3 is not going to give me a solution. The factors with the variables will give me a solution. Coolio? Coolio? Does anybody have questions about that? Okay, so like I said, I'm going to give you a classwork assignment. You're going to do that. Show me all your work. I'm going to collect it and I'm going to grade it, okay? I'm going to give you credit for doing all of the problems, but I am going to grade it for accuracy to see how well you understand, okay? But you'll get a perfect score as long as you do all the problems and show me your work. And then once I collect it from you, then I will pass out your other assignment that's right now work, but if you don't finish it, it's homework, okay? I'm going to pause the video now.